So, turn to the section accuracy versus precision. These are two words that I will use all year long. And I want to make sure we do know what they mean. So here are the definitions. Okay. Accuracy is defined as how close a measurement is to reality. How close a measurement is to reality. If I were to make a measurement, I want that measurement to be accurate. I want it to actually represent whatever I happen to be measuring. I want it to be close. The other day I asked you guys how tall I was. You guys remember that? Anybody remember how tall I am? 5'6.5". Okay. Some of you guys got pretty close. 5'7", 5'6". Some of you guys were a little off. You're like 6 foot. But the closer you are to my actual height, the more accurate you are. That's what accuracy is. Okay? Precision is the reproducibility of a measurement. The reproducibility of a measurement. Can you do it again and get the same measurement as you did before? Now, one thing I've noticed is that if I ask you to do it again, you probably are actually going to get it relatively close. So sometimes I'm going to ask you guys, I want you to do it, and then I want your partner to do it. Because two different people, more likely to actually get a slightly different answer, meaning we might not be accurate. Or at least one person might not be accurate. And then we have to decide, okay, who's accurate here? Everybody follow that? Same person does it 2 times in a row. They usually just like, well, I already did this, so I kind of know the answer. They're biased, and they're going to try and do it again. So I want you to keep that in mind. Try not to be biased based on the answer someone else gave or something you've already come up with. Try to go for it again. See if you do get a different answer. If you get the same one, awesome. That means you might be accurate. If you don't, we might have a problem. We've got to talk about precision here. Okay? So a couple of examples of these. I got some targets here. A target. You want to actually hit the center of a target. That would be accurate. Okay? So this first picture represents accuracy. Somebody hit that right in the money shot. They got it exactly where the bullseye is. The next one, did they hit it on the bullseye? Nope. But are they reproducing it every time? Yep. So first one is accurate. This next one is precise, but it's not accurate. Why might this not be accurate? Why might you shoot an arrow and hit the same spot every time but not hit the bullseye? Yeah. Aiden.
Making the same mistake every single time.
Making the same mistake every single time. And it might not even be your mistake. A lot of things like this, they might have like a scope, something like that. What if your scope's a little off? Or whatever you're using to like line it up. Or maybe, this is an arrow, so we'll use wind. Maybe the wind is blowing, and they're not taking that into account, so the wind always blows it off to the left. I don't know. But it's precise. They're good at doing it over and over, but they're not getting the right result, the accurate result. This next one would be accurate and precise. That's what we want. Same result over and over again, and close to reality. And this last one is just all over the place. It's not accurate. It's definitely not precise. Okay? Now this is a metaphor. Let's actually do some measurements here. All right? So I'm going to exit out of this. Okay. I have an object. All right? I want to know how long this object is. I'll put it under the camera so you guys can all see it. It's a little shiny. There's my object. It's just a chunk of metal. How long do you think it is? I know it's hard to see on the camera, but how long do you think this is lengthwise? Without any tools. Yeah, Sarah.
2.5 inches.
2.5 inches. Okay. Anybody want to give that to me in centimeters since my rulers are all in centimeter?
Um,
I know we're all inch people, but it's hard to do inches with quarters and sixteenths and stuff. So I'm going to use centimeters. Centimeters about that big.
yeah, it's why.
Okay, so what do you think, Bella? 10, 15 centimeters? Are we very accurate? No, because it's difficult to be accurate without a measuring device. So I'm going to use a ruler now. Okay, this is a special ruler made out of paper that I created for this exercise. Just line it up. Okay, so our first guess, I'll write our first guess up over here, was 10 to 15 centimeters. Okay, now that I have a ruler, were we accurate? Okay, how long is it now? Five, 6, 7, 8.
Let's say 8.
We're getting a little like more in a range though, right? It's a little more accurate. We follow that? We're getting a little closer to reality here. So let's say it's more than half though. You guys see that? Why don't we go 6 to 8 centimeters? Okay? 6 to 8. Now let's get a better ruler. Because that's a terrible ruler, isn't it? It's all about the better rulers. Okay, how long is it?
6, 7 months.
Okay, we are no longer arguing over whether or not it is 6, 7, 8 centimeters. We're now arguing over what the decimal place is. Do you guys see that? So we know it's pretty accurate here. We know it is at least 7 centimeters. Okay? 7 point something. So let's take a guess. What's that something? 6. Is that a reasonable guess? Okay, so 6. 7.6 centimeters. That is more accurate than that, and that is more accurate than that. Okay? So, accuracy. We're getting more and more accurate as we go. Okay? Now I'm going to use my final ruler. The best one. Make sure it lines up here. So hard to get it right on the edge. You got to get right on that edge in order to be accurate, right? Does that look good? Yeah? Okay. So what is it? 7 points. I say it's slightly under 5. Did you guys say that? Ever so slightly. So why don't we go 7.4 8? Is that a reasonable guess? This would be the most accurate, and these are all, like, they're not wrong. We're not trying to lie here, we're not trying to have a wrong answer. They're just, the tools we had in order to measure them were not that great. I could actually get a better tool and go even further. It's called a caliper. I don't have one. But I could actually get more decimal places from there. So the decimal places, how many digits I have, it's important in a measurement. With this ruler, I can get to the tens to the hundreds place. Like, I got lines for the tens and then kind of estimate in between them, and I can get to the hundreds place. This one, there's no way I can get to the hundreds place because there's no lines for the tens place. So I'm going to kind of estimate it on the tens place. This ruler, I can't really even get a tens place. I'm going to be estimating it on the ones place. We follow that? So there's an estimated digit here. So let's go back to accuracy versus precision again. In a couple of examples. If I have a series of close measurements and I made it, but I did not zero the electronic balance, is that accurate? No. There's a clear mistake here, right? So that's not going to be accurate, but is it going to be precise? Yeah, I'll probably actually get the same result every single time, as long as I don't mess up the zeroing. As soon as we notice it's not zeroed, though, we're going to fix it, and we're not going to be precise anymore, but now we're going to be more accurate. So, next one. The accepted value of the density of water is 1 gram per centimeter cubed. The following experimental measures were made. They're trying to get the density of water. 1.0, 1.0, 1.0, 1.0, 0.99 grams per centimeter cubed. Are those accurate? Pretty accurate. What about the last one? Is that accurate? Get a lot of people who say no. It's really close though, isn't it? It's really, really close. It's 0.01 off. 0.01 off. I'd say that's close enough. Remember how we're kind of estimating? Like that last little digit, that last decimal place? I'd say with your last decimal place when you're measuring is a reasonable guess, close to each other, then yeah, it is accurate. And of course these are precise because they're all close. Okay? Let's talk about when you're not accurate though. So I have 2 students conduct a laboratory experiment. They wanted to determine the density of water. We just discussed what the density of water is, 1.0. Here are the results. First student said density of water is 1.10 grams per milliliter. Second student, 1.25 grams per milliliter. Third student, 0.097 grams per milliliter. And fourth student, 0.83 grams per milliliter. Are these students accurate? Some of them are not. Are all of them not accurate, though? Or some of them kind of close? I think student 3 is the closest, right? So we might be able to say he's accurate. Are they precise? No, I wouldn't say this time they're precise. I want to talk, though, about calculating the percent error. So there's a way to calculate like how close you are. Here's the formula. Percent error is equal to your error. It's the absolute value of your error. Okay, whether you were too high or too low, whatever your error might be, the absolute value, divided by what the accepted value is times 100. In order to figure out what your error is, it's the difference between the accepted value and what you got. The difference between the accepted value and what you got. Now, sometimes you're too high, in which case you're going to have a negative number. In some cases you're too low, which means you're going to get a positive number. That's why it has to be the absolute value of there. Okay? Absolute value of your error, whether it's positive or negative. Just throw that number there. How off were you? Divided by the second value. The accepted value, sorry. Okay? So let's go back to these students. Student 1, let's calculate their error. Okay? The accepted value is 1.10, or excuse me, 1.0, and the student got 1.10. So 1.10 minus 1.0. 0.10, right? There's their error. So their error is 0.10. They're 0.1 off. 0.10 divided by the accepted 1.0 times 100. %. They're about 10% off. That would be their percent error. The next person. How far off were they? Go ahead and do it yourself. How far off were they? Lauren? 25% off. Okay? Questions? What about student 3? Anybody have that answer? They are 3%. And the last student, I'll just give it to you. They are 17%. Oops. So before I said student 3 is the most accurate here. Student 3 is the most accurate here. And I'd say anything 10% or less is probably pretty good. Okay? All right. I want to talk about measuring devices. This is a ruler. You've all used rulers, I hope, before. Okay, we'll use rulers occasionally. The thing that people might have some difficulty with is this. This is a graduated cylinder. A graduated cylinder is for measuring volume, liquid volume. So I have water. I want to know how much water, how much space it takes up. So I'll pour it in here and I read the lines here. But it's a little tricky because the water doesn't sit flat in the container. The water will actually curve. Okay, it's attracted to the sides, and so it will actually curve up the edges. And so when you're reading these, you see like a little smile in here. That's called a meniscus. So the point where you should read it is not at the top where it's curving up, because some of them they'll curve up a lot and some of them they'll curve up just a little. So we don't want to read it at the top. We want to read it wherever it falls at the bottom. That's the most accurate reading, wherever it is at the bottom of that curve. Everybody see that? Now, we just talked about being accurate and reading between the lines. What would you guys say the best reading for that first one would be? It's definitely more than 36. Less than 37, though, right? So 36 point something. 36.2? I don't know. What did I put here? I put 4. We are going to argue over that last digit, because it is, in fact, estimated. Okay, so I want you guys to write down what you think it was before you saw my lovely slide here. Okay, it's between 36 and 37. How close do you think it is? Go and write down whatever you want. You got it on your sheet, actually. I think it's 36.4-ish, but anything really is acceptable there. Like, as long as you're talking about the tens place, that first decimal. This next one, what would you guys say that one is? Come on. Sarah?
3.61.
3.61. Okay? 3.6, and then you get that you're kind of estimating on that digit there. So go ahead and write down what you think this is. She says 3.61. Maybe you thought 3.62. How many of you guys think it might be right on the line, though? Okay? How would you write it if it's right on the line? Because you do get that extra digit, right? You should be writing another digit there. So if you think it's right on the line, the best way to do that is to write a 0 at the end. 3.60, I think it's exactly 3.6, not 3.61, not 3.62. Okay? Now, I know, I actually agree with you. I think it's 3.61, but I have to make the point of what do you think it's right on the line, you know what I mean? Like, this is all slightly up to interpretation. So, it's about arguing over that last little exactly where it is. It's uncertain. We're trying to get as accurate as possible, but it's uncertain here. So, I got 2 more. Go ahead and make an estimated guess on both of these. All right, Savannah, blue shirt. What do you think the first one is? 464. Okay? Other Savannah, what do you think it is? 462. Do you guys see they're disagreeing over... Yeah? 462? You guys see they're all disagreeing over like what the ones place is here. That's okay. It's okay to disagree on that last little bit. That's the one that's a little like iffy here. So it is definitely between 460 and 470. It's not 460, it's not 470, somewhere in between. So you should have a guess as to what it is, but... So I'm going to say 464. Okay. 462 is a perfectly good guess, though. 463 is a good guess. 465 is probably a good guess. I'd say, though, 467 or 468 might be a little high based on the picture, but, I mean, don't just write down what I have. Understand that I'm making a guess, too. Okay? It's interpreted here. The other one, what do you guys think? Sarah?
Can I ask a question?
Yeah, go ahead.
It's really quick. With tests and quizzes, will we have these on quizzes and tests where we have to just like pick that last decimal, and will it be within a certain range?
Yes, I'm gonna I'll have a range that's acceptable.
Okay.
And it'll actually be how many places you have. Like, I would accept anything basically with a ones place. Okay? Like if you put 460, I'd say no. But if you put 461, 462, 463, 464, 465, anything with a ones place is acceptable because that's open to interpretation.
Just at least 3 digits.
Yeah, I'm looking for 3 digits here. And that's one of the things I want to talk about next is counting how many digits you have. In this case, 3. All right? The next one, the last one on your sheet. Can you actually get as many digits here? CJ, what do you think? Around 400? Around 400? What do you think, Matthew? 300? This one's really open to interpretation. 300, 400, I'd say, are both acceptable here. Could you get any further than that? Could you go say 357? Nope. I would definitely not accept that. That's way too many digits here. So 300, 400. I think it's less than 400 because I personally think 400 would be somewhere around here. So I'm like, it's a little less than 400. So I'm going to go with 300 on mine, but it is really open to interpretation. That is a terrible, terrible graduated cylinder here. We want some more lines than that so we can get a little more accurate. But really I only get one digit. You guys see that? One digit. When I say digits, there's a technical term called significant figures. Significant figures. That means how many digits do I actually know? Okay, in this case, I know 3 digits. Okay, in this case, I only know 1 digit. So this would have 3 sig figs. This would have 1 sig fig. 3 significant figures, 1 significant figure. So, kind of outline my terms here. What's a significant figure? How many digits do I actually know? How accurate is it? Okay, so last slide. This idea of uncertainty. You are always going to make an uncertain digit. Always measure the one place past wherever those lines are, the graduations listed on the equipment. Every single one of your measurements should have at least one uncertain digit. Whatever the last digit is, that's the one we're arguing over. If you go past what the lines are, you're basically saying, I know this really, really well, when we're not arguing over like the ones place, we might be arguing over the tens place. So keep that in mind when you're making your measurements. You want to go to the places that you know, and that's it. Don't go any further. And make one past the lines you have. Just kind of estimate in between the lines. That's our uncertain digit. Okay? Questions?